Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 32 of mathematical physics. We are in which this is the third part of the probability, in which I'm going to discuss Gaussian distribution, that is normal distribution, and exponential distribution, and I'll do some questions as well. Okay, and also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack exams related to physical science. Okay, so I'm going to start. So Gaussian distribution. Okay, Gaussian Gaussian distribution. Gaussian distribution. Okay, this is also called normal distribution. Okay, normal distribution, important one. Okay, so Gaussian distribution, or we can say normal distribution. Okay, so here meanwhile just let me check whether I'm audible or not. That is very important because many times I have faced this issue. This is also called, yes, I'm audible, so I'm going to proceed further. So Gaussian distribution, that is normal distribution. Okay, so in Gaussian distribution, function is fx is proportional to e to the power minus x square, or fx is proportional to e to the power minus mu minus x whole square. Okay, so I'll draw the graph for this. Okay, so this is like this. This is the Gaussian distribution. Okay, this is like this. It is not looking exactly, so what I'll do like this. Okay, this is the Gaussian distribution curve, guys. Okay, this is fx, and this is very important curve, guys, so you need to note down. Okay, so fx equal to x equal to mu here. Okay, so this is like this and this is like this. Okay, here this value and this value. Okay, these are the values. So here this is mu minus sigma and this is mu plus sigma. Okay, and second this one and this one. This is mu minus 2 sigma and this is mu minus 2 sigma. Okay, this is the Gaussian curve, guys. Okay, Gaussian distribution curve. Okay, and here the value of fx is 1 upon sigma root 2 pi. Very important, 1 upon sigma root 2 pi. There are questions, okay, asked in NET and other exams. 1 upon fx equal to 1 upon sigma root 2 pi e to the power, that is exponential minus x minus mu whole square upon 2 sigma square. Okay, mu is the average. Okay, sigma is that variance. Okay, this one, very important formula, and this curve is also very important, guys. We'll solve one question using the curve. Okay, so this is the Gaussian distribution and this is the value of fx, 1 upon sigma root 2 pi 6 e to the power minus x minus mu whole square upon 2 sigma square. Okay, Well, so here I'll explain something which is important. Okay, I'll make curve again. So this one, this is like this. This is the curve, guys. Okay, Gaussian curve. Okay, this is Gaussian curve. Okay, this is the Gaussian curve, and like this part. Okay, this is x equal to mu, that average, okay, mean value, and this is mu plus sigma, and this is mu minus sigma. Okay, and this part is mu plus 2 sigma, this is mu minus 2 sigma. Okay, and guys, this is important, you need to note down this area, this part is 68%, 68.2% almost. Okay, 68.2%. So it means this part is 34.1%. Okay, and this part is also 34.1%. Okay. Okay, guys, so this is important. This is fx and this is x. Okay, I'm writing in red because it's very important. Okay, now so probability, I'm writing here. Okay, so probability, if probability is between mu minus sigma, probability is when x is between mu minus sigma and mu plus sigma, okay. So this probability is, this is almost equal to 68.26, and that is almost equal to 68.2%. Okay, so probability between this value is 68%, between x is between minus mu minus 1, sorry, mu minus sigma to mu plus sigma is 68.2. Okay, this one you need to note down, and you need to memorize it, guys. Very important point. Okay, for exam purpose, if you know this, if it is memorized, if you have memorized, you can easily solve questions. Okay, so this is almost equal to 68.2%. Okay, next is p, which is between, if p is between mu minus 2 sigma. Okay, that x probability when x is between mu minus 2 sigma and mu plus 2 sigma, if that is the case. Okay, then this probability is almost equal to, it is equal to 0.9544, and that is almost equal to 95.4%, guys. Very important, these all result you need to note down. Okay, and memorize it. Next, probability is between mu minus 3 sigma, if x is probability uh, when x is between mu minus sigma and mu minus 3 sigma and mu plus 3 sigma. Okay, then this is almost equal to 0.9974, or that is almost equal to 99.7%, guys. Okay, 99.7%. So this graph is very important. This part is 68%, this part is 34.1%, this part is 34.1%. Okay, this is very important, guys. Okay, so we can take, suppose if we take the value of, like, I'll show you here. If we take value of, like, if we take value is, let value sigma. Sigma is between, sigma is 4, okay, variance, and mu, that is average, mean value is 2. Then for this probability, right, probability is going to be that between this one, mu minus sigma. Mu minus sigma means -2 when x is between -2 to 6. Mu plus sigma means 6. Okay, that is going to be, that is 68%, 68.2%. Similarly, p is between this one, right? This is going to be 2x2. Okay, so p is between this one, p is between this point. Okay, mu plus sigma and mu plus 2 sigma. Okay, 2 and this is going to be 34%. Okay, 34. 34.1%. Okay, 34.1%. Okay, and if we take p is between this one, this and this. Okay, this one, this is the between, this is 95.4%, guys. Okay, between mu minus sigma to mu plus 2 sigma. Okay, so here we'll write mu minus sigma. We have taken the value this. Okay, mu minus sigma means that 2 minus 2 minus 2 sigma 8, right? So minus 6 x and between 10, right? This is the value of 95.4%. Okay, similarly, if you find the between this range, okay, so this range is, this is 34.1%, right? This is 94.4, means this is 47.4, right? So between this value is going to be, I'll show you between this value, that is p. Next page, p is between -2, 10. Okay, this value is 47%, means this value I'm talking about. Show you between this is total 95%, right? So this, from here to this is 47 point, between this. Okay, 47.7%. Okay, between this. Okay, now so now p is between this to this. This is going to be, right, this is going to be that 47.7 minus 34.1, right? So this is going to be 13.6. Okay, this is how we can get the values. Okay, just you need to note down this one, this distance, and these three values. Okay, so the 3 sigma is going to come like that, right? This one, this is mu minus 3 sigma, and this is mu plus 3 sigma. Okay, like this. Okay, so now I will solve one question. Okay, then it will clear your all doubts regarding it. Okay, so question is, a manufacturer a manufacturer a manufacturer a manufacturer produces airmail envelope. Okay, envelope. A manufacturer produces airmail envelope airmail envelope whose weight is normally distributed. Normally distributed means binomially distributed. Okay, there is a binomial distribution, normal distribution. Okay, weight is normally distributed. Okay, with mean, with a mean is given, guys. Mean means mu. Mean 1.95 gram. Okay, and this is mean means mu. Okay, and sigma is given, that is variance, is standard deviation. Sigma is given 0.05 gram. 0.05 gram. Okay, the envelope are sold in lots. In lots. Lots means like bunch of this, like bunch of things. Okay, so that is sold in lots. Like we can tie 10 envelope together, right? That is one lot. Okay, so that is sold in lots of 1,000. Okay, so 1,000 lots means lots of 1,000 means that 1,000 envelopes are packed together. Okay, so lots of 1,000. Okay, how many envelopes? How many envelopes? How many envelopes? How many envelopes? How many envelopes are sold in? My apology. How many envelopes in a lot? How many envelopes in a lot? In a lot, that pack of that envelopes. Okay, in a lot will be heavier. Will be heavier than 2 gram. Okay, this is the question, guys. Understand the question. Question is, a manufacturer. Okay, a manufacturer produces airmail. Okay, manufacturer produces airmail envelope. Okay, envelope whose weight is normally distributed. Weight is normally distributed means this is a case of binomial distribution. Okay, now okay, just wait, guys. There is some issue. Yeah, fine. Okay, so a manufacturer produces airmail envelope. Okay, whose okay, next is okay. So whose weight is normally distributed with mean value of weight is given, that is 1.95 gram, and that standard deviation sigma is given 0.05 gram. Okay, 0.05 gram. The envelope are sold in lots of 1,000. So envelopes are sold in lots of 1,000 means one pack of so there is a one pack of 1,000 envelopes, right? So lots of 1,000. Okay, so in one lot there are 1,000 envelopes. Okay, how many envelopes in a lot will be heavier than 2 gram? So we need to find how many envelopes. Okay, how many envelopes in a lot will be heavier than 2 gram? Okay, so average weight of that envelope is 1.95 gram. This is the average, right? So we have to find out how many envelopes in a lot will have weight which is heavier than 2 gram. Okay, that's what we need to find out. So we'll use this binomial distribution. Okay, so for that I'm going to make this one figure first. Okay, this is given like this. Okay, this is like this. Okay, so here this is given. This is 50% given. Okay, 50% and this is 50%. This is 50% and 50%. Okay, and this we know this value. I have already explained. This value is 68.2%. Right? It means this value is going to be 34.1%. Right? This we know. Okay, and this is okay. Yeah, and this is mu. This value is mu, and this is mu. This is mu minus sigma, and this is mu plus sigma. Okay, this is the one. This is 50%. Okay, this is 50%. This is given 50%, and this is mu, and this total value we know that this is 68%. Okay, normally distributed. Now we have been given value of mu is 1.95 gram, right? And sigma is given, that is 0.05 gram, 95 plus 0.05, this is 2 gram, right? And mu minus sigma is going to be 1.95 minus 0.05, this is 1.9 gram. Okay, mu minus this we have got. Okay, and this is okay. So this is from here, this is 50% and this is 50%, and this is actually 68%, and this is 68%, right? And this is 34%. Okay, so from here we can get in next page. We can get that is 68%, that 50% minus 34.1%. Okay, we'll find this is the 50%, right? 50% minus 34%, right? This is going to be, if you get it, 34.1%. This value is going to be 15.9%. Okay, if you get this is the 50%, but this value is 0, right? 68.2%. This from here to here, right? And from mu minus sigma to mu, this is 34.1%. Okay, so if you subtract 50%, if you subtract 34.1% from 50%, this value is going to be 15.9%. Okay, so this implies 15.9% into, because there are 1000 in a lot, there are 1000 envelope, right? This is, and this will solve it. So this is going to be 15.9% means 15 into 1 upon 100 into 1000. This will get cancelled, and this is going to be 159. So this means 159 envelopes in a lot have weight more than 2 gram. Have weight more than 2 gram. Okay, so 159 envelopes more than 2 gram. Okay, so this is the answer, guys. Okay, so we should know this this value. Okay, this is 50%. This is the 50% part. Okay, for complete this part is a 50%, this part of 50%, and this 50% part value is this. What we'll do is we'll subtract 50% from that 34%. 34.1% from 50%, we'll get this value. And because there are 1000 envelopes in a lot, we'll multiply by 1000, that 15.9%, we'll multiply by 1000. So, and then we'll put the value, and we will get 159. It means 159 envelopes in a lot have weight more than 2 grams. Okay, I hope you have understood it, guys. Okay, you have got it. Next, guys, next is this one, exponential distribution. So what is exponential distribution, guys? Okay, exponential distribution. Exponential distribution. Exponential distribution. So exponential distribution is function is fx is defined as this, fx equal to lambda e to the power lambda x. Okay, lambda e to the power lambda x, lambda e to the power minus lambda x. There's a condition if x is greater than 0. Okay, and this fx value is 0 if x is less than 0. Okay, this is important thing. So fx value is lambda e to the power minus lambda x, lambda e to the power minus lambda x, where x is greater than 0. Okay, and if x is greater than 0, greater than equal to 0, then value of fx is lambda e to the power minus lambda x, and fx value is 0 if x is less than 0. Okay, x is less than 0 means this. Okay, well, so where lambda is decay rate probability. Okay, decay rate of probability. This is exponential distribution. Okay, decay rate of probability, decay rate of probability. Okay, and we'll find mu, that is average of x. Okay, average of x is going to be integration 0 to infinity x, this one fx, right? This is lambda e to the power minus lambda x. Okay, so dx, right? So this is going to be, we'll use gamma function, right? Factorial upon 1 minus gamma, this is e to the power minus lambda, right? Lambda is already there, right? Into gamma to the power x to the power n plus 2 gamma square, right? 1 upon lambda, 1 factorial upon 1 lambda into 1 factorial upon 1 upon lambda whole square, right? And this, if you solve it, this value is going to be lambda. Okay, so this is the value. So, and here the mu value, this is average mean value is for case of this case of exponential, in case of exponential distribution, value of mu is the value of mu, that is average. So this mean mu is, or that is x, is equal to 1 by lambda. Okay, this value is 1 by lambda, guys. My apology, because this is going. Have we made any mistake? I think we have made mistake. Let me just check, guys. Okay. This is 1 upon lambda, guys. My apology. Yeah, because lambda will get cancelled, right? So this value is going to be 1 upon lambda. Okay. So this value is 1 upon lambda, and here mu value is 1 upon lambda. Okay, 1 upon lambda. Well, and also, guys, here one more thing I would like to tell you, mu equal to sigma, standard deviation, and the mean is equal. Okay, and mu and sigma value is same, that is 1 upon lambda. Okay, mu equal to x equal to 1 upon lambda. Okay, so sigma is also, and the exponential function is like this, guys. Okay, I'll show you this one. This is lambda, this one x fx, and this is the exponential function, guys. Okay, this is the lambda. Okay, So this is exponential function, and this value of this one value of mu and sigma is equal. Okay, mu is, that is mean value is 1 upon lambda, and also standard deviation, that is sigma, is 1 upon lambda. Okay, 1 upon lambda. So this is the one, guys. Okay, well, so this is the one, this is the distribution, right? And I'll solve one more question, guys, for it. Okay, one question I'm going to solve. Okay, then I will stop, and in next class I'm going to start numerical analysis. Okay, important one. So there's a question I'm going to solve, okay, for you. Probability question. Good question, guys. Question is, the outcomes the outcomes of an experiment the outcomes the outcomes the outcomes of an experiment are represented outcomes of an experiments are represented by the points by the points by the points in the square. Okay, so outcomes of an experiment are represented by points in the square. Okay, bounded by x equal to 0, y equal to 0, and y equal to a, and x equal to a and y equal to a, x equal to a and y equal to a. Okay, in xy plane, in the xy plane, in the xy plane, if the probability distributed, if the probability is distributed uniformly, then probability that x square plus y square is greater than a square. That's we need to find out, and we know x square plus y square equal to a square is circle of equation. Okay, that is equation of circle. So this is the question, guys. The outcomes of an experiment are represented by the points in the square bounded by x equal to 0, y equal to 0, and x equal to a, y equal to a in the xy plane. If the probability is distributed uniformly, then probability that x square plus y square is greater than equal to a square. That's we need to find out. Okay, and this we know. Okay, so I'll solve it. First I'll draw this here, the figure which is given. This is the circle given, right? Okay, and this is the square. this is the square, guys. Okay, this square, and this is x equal to 0, y equal to 0, and this is x equal to a. Okay, and this is y equal to yx. Okay, and this is a, y equal to a. Okay, this is a, this is a. Okay, this is a, and this is a. This distance is a. Okay, and this is a. Okay, this is a circle, and this is the square. Okay, and now we need to find out the probability that we need to find out then the probability that x square plus y square is greater than a square. That's what we need to find out. Okay, and all the outcomes of an experiment are represented by points in the square bounded by this. Okay, if the probability is distributed uniformly. Okay, probability is distributed uniformly, right? Now we need to find out probability that x square plus a square greater or equal to a square. So that probability we need to find out. Okay, so how we are going to find it? Now first we'll find shaded area. Shaded area means this area. Okay, shaded area is going to pi a square by 4. How? Because this area of square is, this is sides are a, right? A square, area of square is a square minus this is the one quadrant of the circle, right? So the the area of the circle is pi r square or pi a square, because radius is a, right? Pi a square. Okay, pi a square. So here pi a square, right? And there are 4 quadrant of circle, right? So this is going to be the area of one quadrant is going to be pi a square, that is pi a square by 4. Okay, this is like almost equal, right? A, like this. Okay, so this is the shaded area, guys. Okay, or we can say a square will take common 1 minus pi by 4. Okay, now we'll find probability. Probability is shaded area a square into 1 minus pi by 4 upon total area, that is area of shaded area upon total area. Total area is area of circle. A square will get cancelled, that is 1 minus pi by 4. So probability then probability that x square plus a square greater than a square, x square plus a square greater than a square, okay, is going to be 1 by pi by 4. This is the answer, guys. Suppose it is given that we have to find probability that x square plus y square less than a square. My apology, this is greater than less than a square, right? In that case, what we will do, total probability minus the probability which is greater than a square, right? 1 minus pi by 4, right? So this is going to be 1 minus 1 plus pi by 4. So this is going to be pi by 4. Probability that the probability that the a square plus y x square plus y square less than a square is pi by 4, and the questions is the probability, then probability that x square plus a square greater than a square is this 1 minus pi by 4. I hope, guys, you have understood it or you have got it. Okay, so well, guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel, watch my free live lectures which are going to help you to crack the exams related to physical science. And also, guys, I have created playlists so for each subject, so you can watch my detailed courses by going to playlist. Okay, you'll get different courses. Okay, and you can check and watch according to your requirement. Okay, guys, thank you so much. Bye now.